By the end of the course, you'll have an excellent grounding in the fundamentals of sports analytics. My name is Steve, and I'll be your instructor for the course. I'm an expert in data, AI, and sports, and have 20-plus years of experience. My goal in this course is to pack that 20 years into a few hours of course time. Note that for our online courses, while I create the content and hands-on demos, I work with a professional voiceover team when we produce and publish to the web. You may also see different learning avatars along the way. They'll provide different tips and tricks, best practices, and additional resources for you to use. Jake is our sports scientist, Amy is our data analyst, and Megan is our data scientist. Welcome to Module 5 in our course entitled Introduction to Sports Analytics. This module is entitled Data Visualization for Sports. In this module, we'll focus on sports data visualization and dive into what makes visualizing sports data unique and so critical in the world of sports analytics. In this module, we'll cover the following learning objectives: understand what makes sports data visualization unique and how to approach it differently than other domains, develop the ability to select the right tools and visualization types for different sports data contexts, understand how to create basic visualizations using Excel, Power BI, R, and Python. These learning objectives will be guided by the following themes: general rule of thumb when creating visualizations, how visualizing sports data is different types of tools you can use for visualization. Sports data visualization is more than just creating charts and graphs. It's about telling stories that capture the essence of competition, highlight trends over time, and help audiences understand the dynamics of a game, a season, or even an entire career. One of the key challenges in sports data is its dynamic nature. Unlike static data sets in other fields, sports data evolves rapidly. Think of live game stats like shots on goal, possession percentages, or even injury reports. They're constantly changing, often within seconds. Visualizing this data requires tools and techniques that can adapt to this fast-paced environment. Then, there are the specific metrics that are central to sports analysis, from goals and assists in hockey to win percentages and player efficiency ratings in basketball. Each metric brings its own set of visualization challenges. For example, how do you display a team's performance over a season in a way that's clear and meaningful? How do you compare players from different eras or highlight trends without overwhelming your audience? And let's not forget the most important element: storytelling. In sports, every visualization has a purpose: to inspire fans, guide coaching decisions, or even fuel debate among analysts. Whether it's a graph showing a player's scoring streak or a heat map of defensive zones, the goal is always to create a narrative. A well-crafted visualization can highlight key moments, uncover hidden insights, and engage audiences like never before. Let's start by first discussing the general rules for visualizing sports data. These are universal best practices that will help you create clear, impactful, and engaging visualizations tailored specifically to sports analytics. Let's start by talking about the importance of choosing the right chart type. Sports data comes in many forms, and each type of data lends itself to specific types of visualizations. The chart type you choose is important. It determines how easily your audience can understand the story you're trying to tell. For example, if you're comparing player performance, such as goals scored by top players in a season, a bar chart is a solid choice. It clearly shows differences in performance at a glance. For positional data, such as player shot locations on the ice, heat maps work well. They allow you to identify hotspots and patterns, which are critical in tactical analysis. Line charts are great for showing trends over time, like tracking a team's cumulative points throughout a season. Scatter plots are great for visualizing correlations, such as the relationship between player ice time and goals scored. Remember, always match the chart type to the data you're collecting and analyzing, and the story you're trying to tell. The table here helps you map specific use cases to different types of charts. As you practice and do more visualization projects, you'll get more experience in creating sports visualizations, and will inherently know what chart works best for your project, audience, and story. Now, let's talk about clarity. A good visualization should be easy to interpret. Avoid clutter at all costs. Too much information can overwhelm your audience and obscure the key takeaways. Here are some tips. Limit the number of data points or categories in a single chart. For instance, instead of showing 32 NHL teams in one chart, consider breaking them down by division or conference. Use colors sparingly. For instance, in a hockey visual, highlight one team's data in a distinct color and use neutral shades for others. Label your axes and data points clearly. A bar chart showing player goals isn't helpful if we can't tell which bar represents which player, or what the y-axis represents. Avoid overloading your visuals with decorative elements like excessive grid lines or 3D effects. These can distract from the actual data. Once your visualization is clear, the next step is to emphasize the most important insights. Your audience should immediately know what they're supposed to focus on. For example, in a graph comparing team scoring averages, use annotations to highlight the team with the highest average or a team that shows a significant improvement mid-season. If you're visualizing trends, use markers or arrows to draw attention to inflection points, such as a team's winning streak or a sudden drop in performance. Tell your audience what to look for. Don't assume the data will speak for itself. Add context through titles, subtitles, and brief explanations. Finally, let's discuss accessibility. In sports analytics, your audience might include analysts, coaches, fans, or executives. Each of these groups has different levels of technical expertise, so your visualizations need to be accessible to everyone. Here's how. Use simple language for labels and titles. For instance, instead of saying expected goals per 60 minutes, you could say chances created per game. For non-technical audiences, avoid complex charts like radar plots or box and whisker plots. Stick to more intuitive visuals like bar charts and line graphs. Consider color blindness when designing your visuals. Use color palettes that are distinguishable for all viewers. For instance, instead of red and green, use blue and orange. Provide alternative text or summaries for dashboards or visuals when sharing them digitally. This helps those who may not interpret visual data easily. In summary, effective sports data visualizations depend on choosing the right chart types, maintaining clarity, emphasizing key takeaways, and ensuring accessibility for all audiences. These best practices will help you create visuals that not only tell compelling stories, but also resonate with a wide range of viewers. We're now going to explore the various tools available for visualizing sports data. Let's start with a quick comparison of 4 popular tools used in sports data visualization: Excel, Power BI, R, and Python. Each of these tools and programming languages has its own strengths and is suitable for different types of tasks. First, Excel is great for quick and straightforward visualizations. It's accessible to almost everyone, making it ideal for creating bar charts, line graphs, and scatter plots with minimal effort. However, it struggles with handling large data sets or creating highly customizable visuals. Second, Power BI excels at building interactive dashboards. It's perfect for sports analytics teams who want to share insights with coaches or executives. With its slicers and filters, you can create user-friendly dashboards that update dynamically. Power BI, however, requires a paid license for full functionality. You can get started with the free desktop version of Power BI, which has a ton of features for you to learn. Also, we see Power BI as more of an enterprise play for reports and dashboards. That's where it's strong. Also, you can integrate a ton of data into Power BI, do data transformation and cleaning, and also create data models that sit behind your visualizations. The R programming language is a statistical powerhouse. It's particularly strong when you need to build advanced, customized visualizations or analyze complex data. With libraries like ggplot2, the R programming language makes it easy to create heat maps, box plots, and density graphs tailored to sports data. However, R has a steeper learning curve compared to Excel or Power BI. The Python programming language is versatile and widely used for data science and analytics. Libraries like matplotlib, Seaborn, and Plotly allow for both basic and interactive visualizations. Python is particularly useful when integrating data from APIs or creating real-time visual dashboards. But like R, Python can be challenging for beginners and requires programming knowledge. Now that we've compared the tools, let's discuss how to choose the right one for your specific project. Here are some criteria to consider. The first consideration is ease of use. That is, for beginners or when working with small data sets, Excel is often the easiest to learn and use. Power BI is also user-friendly, but requires some initial setup. The next one is flexibility. If you need advanced customizations, R and Python are the best choices. They allow you to tailor visualizations to your specific needs, such as overlaying shot locations on a hockey rink or creating player heat maps. Another consideration is scalability. For large data sets or projects requiring automation, Python and Power BI stand out. Power BI can connect directly to live data sources, while Python can handle data processing and visualization in one workflow. And finally, you want to consider cost. Excel is often included with standard Office software, and R and Python are open source, making them free to use. Power BI, however, requires a subscription for many features, so budget constraints might influence your choice. Let's focus on Excel, one of the most accessible and versatile tools for creating sports visualizations. While it's not as advanced as some other tools, Excel can handle many common visualization tasks, making it perfect for quick and effective analysis.
In this module, we're going to walk through 4 demos, one for Excel, the second for Power BI, the third for R, and the fourth for Python. In each of these demos, we're going to use the same sample sports data as the starting point. You can download the dataset by using the URL on your screen. Our first demo will use Excel to create a bar chart that compares team performance across point percentage. We'll then port the bar chart into PowerPoint and clean it up for presentation. Let's first open the dataset and explore in Excel. The dataset contains multiple statistics across 4 seasons. We want to answer the question of what season saw the highest point percentage on average in the last 4 seasons? To answer the question, let's first create a pivot table in Excel. We'll use season and point percentage as the 2 variables in our analysis. We'll next get the data out of the pivot table into a separate tab. We can then format the data in the new tab in the form of a column chart. We'll keep the order of the columns chronological. We'll then reformat the visualization to be more clean, consistent, and readable. You can choose here to also change up the colors in the chart to emphasize certain aspects of the visualization. A simple copy and paste into PowerPoint gets the bar chart into a slide deck. Now in PowerPoint, we're going to further edit and clean up the visualization. We'll also add a more intuitive title to the visualization and add any necessary callouts to the column chart. After you've finished, you should now have a decent-looking visualization that follows good principles of design and is easy to read and understand.
Let's now focus on Power BI, a powerful tool for creating interactive dashboards and advanced visualizations in sports analytics. Power BI lets us go beyond static charts and build dynamic, user-driven dashboards that are perfect for sharing insights with coaches, teams, and fans. In this section, we'll cover how to import and manage datasets in Power BI, create dashboards for visualizing performance trends, and use interactive features like slicers and filters. Finally, we'll explore how to share and publish your dashboards for maximum impact.
Let's first walk through a set of completed Power BI reports. These reports were created as a part of the 4 Nations face-off work we did and highlight Team Canada's offense, goaltending, and experience. The first report shows point production. The top visualization shows goals and assists, and the second visualization shows age. This gives you a sense for how different players across age groups are contributing to Team Canada. This report also has filters for position and player. The second report shows goaltending performance through goals against average and save percentage. It also overlays age on both of the visualizations. The filter here is for the goalies. The third report shows point production versus age through a scatter plot. Players towards the bottom right are older players who may not be as productive as younger players located towards the top, middle to left. To show how to create a report, let's take the same sample data and import it into Power BI. After the data is loaded, it'll show up in your data pane. You can collapse and expand the dataset to see what fields are included. You can then use the visualizations pane to add a new chart onto the canvas. Let's keep it simple and add a new scatter chart. For this visualization, let's look at the average point production versus average age for each team. We'll also add a filter to the report for season, When we're done, you can see which teams are above the trend line for being more productive in terms of points percentage and younger, which is towards the center. Older, less productive teams are more towards the right and bottom of the scatter chart. You can, of course, clean up and brand the visualization such that it looks similar to the experience report in the Team Canada set of reports.
We'll now get a bit more complex and delve into the R programming language. Here, we'll explore the power of R for creating customized sports visualizations. R is a favorite among analysts for its flexibility, precision, and extensive libraries. We'll focus on using ggplot2 and other libraries to create unique and insightful sports visualizations.
Let's now take a subset of the original data sample and use season, team, goals for per game, and goals against per game as the 4 variables we'll plot using the R programming language. To do this, we'll jump into RStudio. The first snippet loads the core libraries for the script. The second snippet loads and transforms the dataset so we can plot it. And the final code snippet plots the dataset using a 100% stacked column chart. We've added in some extra configuration so the resulting visualization looks decent. Here, you can see the final result.
We'll next look at Python on how to create powerful and interactive sports visualizations. Python's libraries such as matplotlib, seaborn, plotly, and dash offer flexibility for crafting everything from simple charts to dynamic dashboards. Python also integrates seamlessly with sports APIs, making it a good choice for real-time analytics. Let's start with the fundamentals, creating static charts using matplotlib and seaborn. These libraries are essential tools for data visualization in Python. Matplotlib is a core library that's used to create visualizations and analyze data. Matplotlib is Python's most versatile plotting library. Use it to create line graphs, bar charts, scatter plots, and more. While it requires more coding than Excel, it offers greater control and customization. Seaborn is another library often used to visualize data. Seaborn is built on top of Matplotlib and simplifies the creation of aesthetically pleasing charts. It's ideal for visualizing trends, distributions, and correlations in sports data. When you want to elevate your visualizations with interactivity, you can use Plotly. Interactive visualizations are particularly valuable for exploring sports data dynamically. Plotly enables you to create interactive visualizations such as zoomable line charts, hoverable bar charts, and draggable scatter plots. It's great for making data exploration more engaging. And lastly, let's explore Dash. Dash is a Python framework for building interactive web applications. It's ideal for creating dashboards that combine visualizations and user inputs, such as filters and sliders. One of Python's greatest strengths is its ability to integrate with APIs, allowing you to create real-time visualizations. Sports APIs provide live data, such as scores, player stats, and game events. By integrating APIs with Python, you can build dashboards that update in real time. To summarize, Python is a versatile tool for sports visualizations, offering static charts with Matplotlib and Seaborn, interactive graphics with Plotly, and dynamic dashboards with Dash. By integrating APIs, you can create real-time visualizations that keep stakeholders engaged and informed.
We're going to run a similar dataset, but this time do it using the Python programming language. To do this, we'll jump into PyCharm, which has a community edition that is free for Python developers. The first part of the application loads the core libraries, the second part of the code loads and transforms the dataset so we can plot it. And the final part of the code plots the dataset using a 100% stacked column chart. We've again added in some extra configuration so the resulting visualization looks decent. Here you can see the final result. As a summary, this module focused on data visualization and covered 4 major tools and programming languages include Excel, Power BI, R, and Python. We explored the tools and programming languages through various topics. First, we covered visualizing sports data. Second, we discussed how different data types require you to use specific chart types, which should be audience appropriate. Third, we covered considerations for design, clarity, and accessibility when creating your visualizations. Fourth, we walked through different tools from simple to complex, providing examples of each tool or programming language in action. And lastly, we covered when to use the different tools and programming languages.